Before we start solving, let's take note of the meaning and the formula of the arithmetic sequence and arithmetic series. An arithmetic sequence is a sequence of numbers such that the difference of any two successive members of the sequence is a constant. The arithmetic sequence formula for finding the nth term is a sub n is equal to a sub 1 plus the quantity n minus 1 times d, where a sub 1 is the first term, a sub n is the nth term, n is the number of terms, and d is the common difference. On the other hand, an arithmetic series is the sum of an arithmetic sequence. The arithmetic series formula for the sum of an arithmetic series is s sub n is equal to n divided by 2 times the quantity a sub 1 plus a sub n, where a sub 1 is the first term, a sub n is the nth term, and n is the number of terms. Now, let's solve the following problems. If three arithmetic means are inserted between 11 and 39, what is the third arithmetic mean? For this problem, we will be using the arithmetic sequence formula, where the last term is equal to the first term plus the quantity of the number of terms minus 1 times the common difference. To get the common difference for this problem, we will have to subtract the first term from the last term divided by the number of terms minus 1. Since the last term of the sequence is 39, and subtract the first term, 11, divided by the number of terms. There are only two given terms in this question, 11 and 39. But we are also looking for the three arithmetic means. So 2 plus 3 makes 5. So 39 minus 11 divided by 5 minus 1 is equal to 28 divided by 4, which is 7. Therefore, the common difference is 7. And if you add 7 to the first term, it will become 18. And then to add it to the next, it will be 25. Add it again, it would be 32. And finally, 39. Hence, the three arithmetic means are 18, 25, and 32 respectively. And since we are looking for the third arithmetic mean, the correct answer is 32. Two arithmetic sequences, 2, 14, 26, and 1, 8, 15 have infinitely many terms in common. Find three of these common terms. 2, 14, and 26 have a common difference of 12, while 1, 8, 15 have a common difference of 7. If we move on to both of these sequences, we will find that they have a common term of 50. Now we will have to look for the least common multiple of 12 and 7, which is 84. Next, add the LCM to the common term. 50 plus 84 is 134, plus 84 is 218. So three of these common terms are 50, 134, and 218. A restaurant has square tables which seat 4 people per table. When two tables are placed together, 6 people can be seated. If you have 22 guests in your party and you want them to sit together in a very long table, how many square tables should the restaurant staff put together? As shown in the diagram, 4 people can seat in one table, while 2 tables can hold 6 people. In this problem, we will use the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. The nth term is 22, the first term is 4, and the common difference is 2. Now substitute the given. 22 is equal to 4 plus the quantity n minus 1 times 2. Therefore, n minus 1 will be equal to 22 minus 4 divided by 2, which is equal to 18 divided by 2, which is equal to 9. So n minus 1 is equal to 9. Next, transpose the 1 to get the equation n is equal to 9 plus 1. So how many square tables should the restaurant staff put together? The answer is 10. The concert hall has 40 rows of seats. The first row has 30 seats and each row after the first has one more seat than the row before it. If the management of the concert hall plans to add 10 more rows, how many more seats will be added? The number of terms is 40, the first term is 30, and the common difference is 1 because each row has one more seat than the row before it. Now, let's look for the 40th term. we will be using the formula a sub n is equal to a sub 1 plus the quantity n minus 1 times d. To substitute the given, a sub 40 is equal to 30 plus the quantity 40 minus 1 times 1. A sub 40 will be equal to 30 plus 39. So a sub 40 is 69. And to find the next term, all you have to do is add the common difference. So a sub 41 is equal to 69 plus 1. So a sub 41 is 70. The 41st term is 70. Since we are going to be adding 10 more rows, the number of terms will be 10. And the common difference is 1. Since they are asking for how many seats will be added, we will be using the formula S sub n is equal to n divided by 2 times the quantity a sub 1 plus a sub n. Our first term will be 70 and our last term will be 79. Let's substitute the given. S sub 10 will be equal to 10 divided by 2 times the quantity 70 plus 79. So S sub 10 is equal to 5 times 149. So the correct answer is 745. What is the 11th term of the sequence defined by the rule a sub n minus 2 plus a sub n minus 1, n is greater than equal 3, a sub 1 is equal to 1, and a sub 2 is equal to 1. To find the third term of the sequence, you have to substitute n with 3. So a sub n minus 2 plus a sub n minus 1 is equal to a sub 3 minus 2 plus a sub 3 minus 1, which is equal to a sub 1 plus a sub 2, equal to 1 plus 1, which is equal to 2. Then, a sub 3 is equal to 2. Notice that to get the next term of the sequence, you have to start by adding the last two terms. So 1 plus 1 is equal to 2, 1 plus 2 is equal to 3, 2 plus 3 is equal to 5, 3 plus 5 is equal to 8, 5 plus 8 is equal to 13, 8 plus 13 is equal to 21, 13 plus 21 is equal to 34, 21 plus 34 is equal to 55, 34 plus 55 is equal to 89. Therefore, the answer is 89.